As our third step in this example, let's take a look at how we could explore those refiner results by kind of playing around with the design grid. We can adjust the variable that we want to sort by. We can take a look at the scatter plot and choose which variables we want to display as the axes, or maybe kind of change the size or color of the data points, kind of based on the variables. We could also maybe kind of look at the design table and kind of choose some specific cases and sort of see what the input and output variables or values are for those different cases. So let's go over and just take a look at that. So here we are looking at the results of our surface panelization efficiency study. You sort of see the number of U panels and V panels that got generated kind of as part of these best case scenarios. So let's go through and just kind of take a look at some of these results. So if I start to sort this around a little bit, and maybe I say, how about if we go for the, what is it? I'll go for the number of panels that are generated versus, let's say, the area of the cutoff panels. Oh, you see kind of a very interesting sort of trade-off there. Let's see if we can kind of figure out what's going on here. So let me, my area of the cutoff panels. There's a lot of area over here. Let me go through and kind of sort that out by the area of the cutoff panels, everywhere from the lowest to the highest. Okay, so if I, for example, try to look at that point, let's figure out what's going on here. This seems to be the worst case. In this case, what is happening is, you kind of take a look at it here, like almost everything is cut off. In fact, you can look at it back over there in the Dynamo preview too. So here, just about everything is cut off. That's not really a very attractive case. And if we started looking at the value there, I think it really just has probably like 1 point. You know, we have another case over here that again is, I think, you know, fairly non-responsive. There's only one panel in the other direction. I guess you actually need 2 panels in each direction to actually start doing anything interesting. And here we actually have a case where we are looking at something a little bit different. Okay, so there you have some full panels, and the cutoff area is getting a little bit lesser. Let's kind of try flipping the order of this around a little bit. So instead, we'll go through and see if we can find the cases that actually have the best scenario. Let's let that flip around a little bit. Okay, so for here, they're in basically ascending order. So this case is the minimum number of kind of cutoff panels, or the minimum area of cutoff panels, but it also has a fair number of panels. It's got a lot of panels in there. Maybe we don't want that so much. So we want to think about, is there some sort of a trade-off in here? Maybe somewhere in the middle, there's a case where we're sort of making this trade-off between the amount that's cut off and the total number of full panels. So yeah, that's what this tool is really all about, is trying to sort of explore kind of really where we are within there. For each of those different points, we can, for example, say what is the full panel area, and you can sort of see as we have less and less cutoff area, or less and less panels, we're getting to be bigger and bigger panels as opposed to these, which are much smaller panels, a lot more of them, less cutoff area, but a whole lot more panels to work with. And this is really kind of what we're after here, is really trying to understand there what the trade-off is here. To really kind of continue with this analysis, we'd probably like to start thinking about the cost, have some sort of a cost factor for the number of panels, some sort of cost factor for just the area of each of those full-size panels, as well as kind of thinking about those cutoff panels and how they might have to be custom constructed. So, you know, you'd like to go further in terms of really understanding that. In terms of now, oops, let's go back and show the data values. Put the scatter plot back on. You can again go to any specific sort of area here and sort of see what the specific number is. So it's going to show us that for this specific case, there we go, it looks like we have 12 by 12. You can sort of see the full panel area. You can see the number of panels and the total area of the cutoff panel, so you can get to that. This other view, which actually shows how things are sort of all related, starts to kind of show you just how each of those different measures kind of stack up. So you can start to see that this specific case is kind of, sort of midpoint on the number of U and V panels. It has the least amount of cutoff. It has a somewhat large number of panels, not the biggest number of panels, but the full panel area is relatively small. Where if we went through and kind of contrasted that to one of these other cases, you can sort of hover over. You can sort of see as I'm coming up here, I have far more U and V panels. The total area of the cutout panels is staying small. The number of panels hasn't grown that much. Or actually, I take that back, it has. Number of panels has grown quite a bit. Okay, and the full panel size hasn't gotten that much better. So this case, compared to the other case, has a whole lot more panels, but it really hasn't, let it generate, it hasn't really reduced the total amount of kind of cutoff very significantly. So maybe that's not so attractive. So again, this is all about just trying to explore what those trade-offs may be, and hopefully this tool gives you a way of kind of quickly kind of comparing the alternatives and what the impact of the different alternative values could be.